Hi children, welcome to the series Blast with the Past. Here we have yet another question, JEE Advanced 2020 exam paper, right? You can see the question is basically nuclear chemistry. Nuclear chemistry is a part of JEE Advanced. Nuclear chemistry linked with the concept of what we learn in kinetics, we can say from the topic content, okay? See the question. Uranium-238 giving radioactive decay to form lead-206 by emitting alpha and beta particles. It initially contained 68 into 10 power minus 6 gram 68 into 10 power minus 6 gram uranium-238. If the number of alpha particles that would emit during the radioactive decay in 3 half-life is Z into 10 power 18, what is the value of Z? So ultimately we need to find out the number of alpha particle decayed in 3 half-life. Okay. So what is happening in 3 half-life? If you start with 1 mole, 1 half-life, it will become 1.5. Again 1 half-life, it will become 1/4. Again 1 half-life, it will become 1/8. So 1/8 mole remain after 3 half-life, isn't it? So how much decayed in 3 half-life? The number of moles decayed will be 7 out of 8 N or X. 7 out of 8 X, where X is the number of moles initially taken, right? So if you have taken 1 mole, 1 mole become half mole become 1/4, 1/4 become 1/8 in 3 half-life. So how much decayed? Decayed is 7 out of 8, all of you know. So if X mole you have taken initially, 7 out of 8 decayed, right? So how much moles decayed? It is 7 out of 8 into number of moles of uranium, 68 into 10 power minus 6 gram divided by molar mass 238. This is the number of moles decayed in 3 half-life. So how many molecules decayed? It will be Avogadro number. 7/8 into 68 into 10 power minus 6 divided by 238 into Avogadro number. This will be the number of particles decayed. What we need to find out is number of alpha particles emitted. How many alpha particles emitted by 1 uranium? 1 uranium-238 is turning lead, right? Lead-206. Uranium-238 92 turn lead-82, correct? 82. So the difference between this will give you the number of alpha particle. 238, 206. It is how much? 238, 206. It is 32, right? That means each alpha particle will cause a difference in mass by 4. Each alpha particle, this is alpha particle, each alpha particle will cause a difference by 4. So it is 8 alpha particle, isn't it? It is 8 alpha particle. 238, 206. It is 8 alpha particle, isn't it? 32 is the difference, 8 alpha particle. And how many beta particle? Each alpha particle will cause a difference 2. So 8 alpha particles, see how much difference it is? 8 alpha, but 16 should be the difference. 16 should be the difference. The difference is only 10 units. That means 6 beta particles. So easily we can identify how many alpha, how many beta during the decay. 8 alpha particle and 6 beta particle. You get that picture. Now the number of molecules decayed is this much. Number of alpha particle released will be into that. So it is 7/8 into 68 into 10 power minus 6 divided by 238 into 6.023 into 10 power 23 into 8. That will be the answer. I repeat, each particle when decayed, the difference of mass is 32. So number of alpha particle will be by 4, 8 alpha particle, right? And beta particle also you can find out that, but that's not the point of discussion in the question. So 8 are the alpha particle released by 1 uranium. How many uranium decayed? By 3 half-life. 3 half-life, remaining quantity will be 1 by 8. Reacted quantity will be 7 by 8. 7 by 8 of the taken number of moles. How much is the taken number of moles? 68 into 10 power minus 6 gram is taken. Divided by 238. This is the number of moles initially taken, of which 7 out of 8 is reacted. Means how many uranium particles into Avogadro number? Into Avogadro number. So number of uranium particle decayed is this much. And number of alpha particle released will be into 8, because each uranium release 8 particles. So it will be 7 out of 8, 68 into 10 power minus 6, 238 into this. So what do you get? What do you get? 8 cancels, right? Now take this as 240 and this as 6. So 40, right? 40, right? So this will be 22. 22 with this will be 10 power 16, right? 10 power 16. Now how much? So this gone, this gone, this gone. What remaining is 68 with the 7, 70 with the 7, 70 with the 7. So it is 68 and 7 here also, and there is 4, right? There is 4 here. So it will give you, rather than it will give you 68 with the 4, 128, 70. Now 17 with the 7, it is 9 into 10 power 16. So you get 119 into 10 power 16. That is 1.19 into 10 power 18. Our power required is 10 power 18. So it is close to 1.19. That is 1.2. So the answer will be, answer is 1.2. That is the answer. Z is asked for. Z is asked for. I'll repeat. Uranium 238 turn uranium 206. So each conversion 8 alpha particles are emitted. We are talking about 3 half-life. 3 half-life, quantity remaining is this, quantity reacted is this. And the quantity taken initially this much. So 7 out of that reacted. In number of particles into Avogadro number. So this is the number of particles decayed by 3 half-life. And therefore number of alpha particle will be, each particle 8 alpha particle. Each uranium 8 alpha particle. So total alpha particle will be this into 8. So 7 out of 8. This into Avogadro number into 8. 8 cancels. This cancels, right? 6 with the 240. You get 40, right? And this 40. 10 power minus 6, 10 power 23, 22. That is 10 power 16, right? And 4 with the 68, you get 17. 17 with the 7, you will get 119 into 10 raised to 16. When you adjust 1.19 into 10 raised to 18, this is the power we are given in the question. So 1.19, close figure will be 1.2. Right? That is one question in this series. We'll meet in the next one. Bye. See you. Take care.